Let us understand about Zener diode. We've already discussed that when reverse bias voltage for any diode is increased, a critical voltage called breakdown voltage occurs, where reverse current increases sharply to a higher value. This was first given by the American scientist C. Zener. Therefore, breakdown voltage is sometimes called the Zener voltage, and sudden increase in current is known as Zener current. The breakdown or Zener voltage depends upon the amount of doping. Let us recall about the term doping, where doping is the process of adding impurities to a pure semiconductor. If the diode is heavily doped, depletion layer will be thin and breakdown occurs at low reverse voltage. Hence, a lightly doped diode has a higher breakdown voltage. Therefore, we can say that a properly doped semiconductor diode has a sharp breakdown voltage, and this diode is known as Zener diode. The figure here shows the schematic symbol of a Zener diode, where it looks like a normal diode symbol except that the bar is turned to Z shape. Points to be remembered about Zener diode. A Zener diode is like an ordinary diode except that it is properly doped so as to have a sharp breakdown voltage. A Zener diode is always reversely connected, that is, it is always reverse biased. A Zener diode has sharp breakdown voltage called Zener voltage, denoted by the letter Vz. When forward biased, its characteristics are just that of an ordinary diode. The Zener diode is not immediately burnt just because it has entered the breakdown region. As long as the external circuit connected to the diode limits the diode current to less than burnout value, the diode will not burn out. Finally, Zener breakdown voltage depends on its value. That is, when we choose 6.1 volt Zener diode, then its Zener breakdown occurs exactly at 6.1 volts.